In the last video, I finished with my first example of using a stream in code. I'll display it here on the slide. This entire chain of operations is what's called a stream pipeline. The source of the stream is where the data elements are coming from. In our example, it's coming from a list, bingo pool. All pipelines start with a stream, so in this example we need to call the stream method on the bingo pool list to get a stream. There are a lot of other kinds of sources and ways to create new streams, including infinite streams. I'll be discussing these shortly. Stream pipelines end in a terminal operation which produces a result or side effect. In this example, the for each operation executes a consumer implementation. This prints out some data about each element that was processed and its current state. A terminal operation is required. There are many different kinds of terminal operations returning many different types. The for each operation, along with the similar for each ordered operation, are the only ones that don't return anything. They're void, in other words. I'll be reviewing all of these with you over the course of this section. Everything else between the source and the terminal operation is an intermediate operation. An intermediate operation is not required. You can have a pipeline that has just a source and terminal operation, and these are quite common. I'll be giving you examples shortly. Every intermediate operation processes elements on the stream and returns a stream as a result. Knowing this piece of information will help you identify a terminal versus intermediate operation in the Stream API. Let's review the stream documentation. As we scroll through these methods, pay attention to the return type. For example, the first two, allMatch and AnyMatch, return a Boolean. These are terminal operations, as are the next two, which are overloaded versions of a function called collect. Scrolling down a bit, you can see now distinct, drop while, and filter here. I used filter in my example code. This operation returns a stream and is an intermediate operation, as are distinct and drop while, and others that return a stream. Some return special streams for primitive types like double stream, int stream, and long stream. You'll hopefully remember that the stream interface, which is generic, can't be typed with a primitive. Java provides these special streams when you don't want the overhead of a wrapper type. I'm going to cover most of these operations and what they mean and how to use them. What I also want you to see is that nearly every one of these uses some kind of functional interface. You can see consumer in the for each, supplier in generate, a unary operator in iterate, a function in map, and so on. It's definitely a lambda expression landscape. If you feel like you might be a little weak on lambdas or method references, I hope you'll give yourself a review of that subject from the previous videos in this course. Lambdas and streams were built for each other and are both part of Java's tilt towards functional programming. Finally, you can always just search for terminal in your browser session to scroll through the different terminal operations. If I keep hitting next, I'll work my way through the terminal operations. I could do the same for intermediate as well, but I won't do that now. There are some additional topics I want to discuss about the pipeline before I get back to the code. Scrolling almost all the way back to the top of this page, I want to highlight the next important point. Streams are lazy. Computation on the source data is only performed when the terminal operation is initiated and source elements are consumed only as needed. If you're anything like me, you may be asking, okay, but what does that really mean? Without worrying about semantics, I want you to imagine the stream pipeline as a black box. The source is your input, the result of your terminal operation is your output. Everything in between isn't going to happen until something tells that terminal operation to start. What actually happens in that black box may not happen exactly as you've described it or in the order you've specified. This is quite different from chaining methods, where the execution of every method is guaranteed to occur, and it occurs in the order you defined it against a known set of elements. Execution of the intermediate operations is dependent, first on a terminal operation being specified, and second on an optimization process occurring. Stream computations are optimized for performance. What this means is that your stream pipeline is kind of a workflow suggestion. Before the process begins, the stream implementation will perform an evaluation to optimize the means to the end. It will determine the best way to get the elements needed and the most efficient way to process them to give you the result you've asked for. The result will be consistent each time, but the process to get there is not guaranteed to be. Optimizations may change the order of the intermediate operations, it may combine operations, or even skip them altogether. For this reason, you should avoid side effects in your intermediate operations. For example, in the code I've been working with, I requested that my stream be filtered by the G and O labels. If the source stream only contained G labels, this filter might be omitted altogether. If I'd included code in the Lambda to do something else, to increment a counter on another object or something like that, it may never be executed. I'm going to come back to this point again a bit later in the intermediate operations video. Before we move on, let's get back to the code for just a minute. First, I want to remove the last couple of statements that print out the first 15 strings in the bingo pool. Next, I'll comment out the statement that has the terminal operation for a moment, and then the statement above that with a semicolon. IntelliJ is giving me a warning, but the code compiles and I can run it, which I'll do next. None of these operations were executed. I've said they won't be executed until a terminal operation is executed, and I've also said a terminal operation is required to complete the pipeline. In this case, I haven't included a terminal operation in my pipeline at all. Can I make a call to the terminal operation later? Let's try that. I'll assign the result of the pipeline to a local variable, just using var for the type, and name the variable tempStream. Next, I'll use that variable to call the for each operation on in a separate statement, passing it the same lambda as before. This all compiles, and if I run it now, this time I get a result. You don't have to build your pipeline all in one piece. It's important to understand, though, that unlike the chaining of method calls on other types, these operations don't get executed until line 54. Okay, now let's say I want to use my stream to do something else. Maybe next, I want to print things out in lowercase. I'll copy line 54 and paste it at the end of my method. I'll change the S that gets printed out to S dot to lowercase. I have a warning from IntelliJ. If I hover over that, the message says that stream has already been linked or consumed. What's that all about, you may be wondering? I will try to run this anyway, since it's just a warning. Running it gives me an error. This one says stream has already been operated upon or closed. Let me remove that last statement first and talk about what this means. Once you invoke a terminal operation on a stream, you can think of the pipeline as being opened and the flow beginning. The flow is allowed to continue until all processes have been performed and a result produced. At that point, the valve is shut and the pipeline closed. You can't turn it back on or reuse it for a new source. If you want to do the same sort of thing with a different variable for one of the intermediate operations, you'd need to set up a new pipeline. Now that you have a bit of understanding about the stream pipeline, let's review different ways to create sources for your streams. We'll start on that in the next video.